Okay. So this is an example for a geometry problem where I promise that the Pythagorean theorem is all over the place, even when it doesn't look like it. So there is not much right angles here. And yet this is going to turn out to be an application of the Pythagorean theorem. So what we have is a square and a circle. And I think it's very important you draw a reasonable picture, scaled if it's possible. Because if you manage to draw a reasonable picture, you understand the relations that are present on the picture. So what's going on here? At this point here, the side that forms the side of the square is a tangent line to the circle, and the opposite two vertices are on the circle. Now let me just go away for a moment and state just for the record that, so if you have something like this or something like that, then the center of the circle and the center of the square coincide. That's not the case here. One thing you can imagine is the centers would coincide if these 2 points would be sides. So you can sort of visualize that. Suppose a square and a circle had the same center. This was pulled to the left a little bit. But vertically, they're still on the same line. So the center of the circle is here. The square was pulled a little bit to the left. So something like that. We don't know which one we're going to use, but I'm going to circle the one that's the center of the circle. So we know it's for the circle. Okay. And so what we know is that this difference here is 1. And in exchange for that information, we need to know what the area of the square is, which is pretty much the same as the side of the square. So we should first use all the information that is given to us. So we should use that this vertex is on the circle and that this here is a tangent line. Tangent line automatically gives us right angles, right? These two lines are perpendicular. So I usually call the radius of the circle r, little lowercase or uppercase. And I don't want to call the side x because I don't want to deal with fractions. So instead, I'm going to call this x. So r is the radius of the circle and x is half the side of the square. So the area is not going to be just x squared. It's going to be 2x squared, right? Because one side is 2x and that's 4x squared. Let's not forget about it because we might be celebrating finding x so hard that you accidentally find x squared when we really need 4x squared. Okay. And if we are going to run with these two unknowns, we should have two equations. Let's see. So I see a right triangle here. So this is how we're going to be able to use that this vertex of the square is on the circle. What's the circle? The set of all points equidistant to the center. So if you connect this point with the center of the circle, that should be the radius. And then this is x. And this here is not the radius again, but one less than that, r minus 1. So one equation between x and r would be the Pythagorean theorem stated for this triangle, which is x squared plus r minus 1 squared equals to r squared. And if we work this a little bit, x squared plus r squared, you see r squared is going to cancel out, right? We can subtract r squared from both sides, and then we get x squared minus 2r plus 1 equals 0, or x squared equals 2r minus 1. Okay. But we need to squeeze out another equation for that from this situation. And that would be the following. That took me a long time to find. If we go from one side of the square to the other side, that is 2x. And if you draw in the diameter, which means we go from one end of the circle along to the other end, that's 2r. So the green line is 2r, the red line is 2x, the difference is 1. So actually that's a simpler equation. And that says that 2r equals to 2x plus 1. 2r, the green, is 2x plus 1. Interesting. This is going to look strange, but I see 2r minus 1 here, 2r minus 1. So instead of substituting, say, r, why not go for 2r minus 1? 2r minus 1 is 2x. So we got this very simple equation. If we substitute 2r minus 1, we get x squared equals 2x. Now that's a quadratic equation. So we're going to reduce one side to 0 and factor and apply the zero product rule. The two solutions are 0 and 2, and this one can be ruled out because x should be a positive number. So this is x, and therefore the area, which remember, it wasn't x squared, it was 4x squared, is 4 times 2 squared, is 4 times 4 is 16. Okay. So that's how you do it. Don't expect to get these two equations immediately. You're going to draw in lines and try things, but you have to keep at it. Even when I solved this problem for the first time, it took me quite some time and quite a few pages to draw, to find the connections that led to the answer. Thank you for watching.